Welcome, Algebra 1 students. It's Ms. Parsons, and today we're going to be talking about exponential functions. So what is an exponential function? Well, an exponential function can look two different ways. It can be going down rapidly, which we call exponential decay, or it can grow very rapidly, which is called exponential growth. Okay, we see these models used all the time to model things like population growth or even your bank account and getting interest on your bank account. And it looks like y equals a times b to the x power. In this equation, a is our initial value, so how much you started with. Maybe it was how much you initially had in your bank account, or maybe it was how much we started with the population in the year 2000. Then B represents either our growth or decay rate. So a growth or decay rate, if it's growth, it's going to be 1 plus that rate as a decimal. So if it's 20%, our growth rate is actually 1.2. If it's a decay rate, we're going to take 1 minus that rate as a decimal to get our decay rate. So the only things changing here are A and B. We're going to know our initial value, and we're going to know what our growth or decay rate is. So how can we tell the difference between a linear function and an exponential function? Well, we remember that a linear function changes by a constant rate. So we will notice, like in this chart, that the rate goes up by 7 for the y's, goes up by 7 again, and then up by 7 again. So we're adding a constant amount every time, and that's the same things for the y's. We're going to add 3 to both sides, add 3 again, and add 3 again. So when we have a constant change in y's and change in x's, we have a constant slope, which makes this linear. Okay, so we're adding the same thing or even subtracting the same thing every time. But here we can see that from 1 to 3, I add 2. From 3 to 9, I'm adding 6. From 9 to 27, I'm adding 18. So I don't have a constant change here. Instead, we notice that the pattern is that I am multiplying by 3 every time. Okay, so when I have a constant change by multiplication or a constant ratio, then I know that that is exponential. So I have a new car and it's purchased for $15,500. The value of the car depreciates at 7.5% per year. What will the value of the car be to the nearest cent after 6 years? So the first thing I have to do is find out what A is. And remember, A is our initial value. This is how much we initially purchased the car for. And we could tell that it was $15,500. B is going to be my growth or decay rate. So what's happening to this car? Well, it would be great if this was exponential growth, and as we drove it off the lot, it just kept getting more valuable. That would be awesome. But unfortunately, that's not how it works. And when you drive the car off the lot, your car immediately depreciates in value, meaning that it goes down. So we know that it's going to be 1 minus this rate, and we have to turn this rate into a decimal, this percent into a decimal. And we do that by moving the decimal point over to the left 2 times. So 1, 2. So the decimal is going to go here, and we're going to fill it in with a 0. So it's going to be 1 minus 0.075, and 1 minus 0.075 is going to be 0.925. So I've got my A and I've got my B, which means I can put it into my formula, y equals A times B to the x power. So it's just going to be 15,500 times 0.925 to the x power. Now, if I want to know the value of the car after 6 years, 6 years is going to be my x. So I'm going to plug that in, 15,500 times 0.925 to the 6th power. Put that in my calculator, 15500 times 0.925 up to the 6th power, and that car is now worth $9,709.17. So it is worth that much. It is depreciated that much, from $15,500 to $9,709.17 after 6 years. So here I want to find the equation of the exponential function represented below. So remember, we still need 2 things. We need an initial value. We also need a growth rate, okay, or a constant ratio when we're looking at a table. So our exponential function, our initial value is our y-intercept. So here we're looking where the 0 is, and our A is 1. Okay, my B is my ratio, okay? How do I get from one y to the next? Well, here we're going to multiply by 4 every time. That's my B value. That's my growth rate. So my equation, if I have y equals A times B to the x power, take A times B to the x power. That is my equation. Okay, I want you guys to take a few moments to write these steps down in your notebook. I'm going to give you 2 points, and you're going to have to tell me you're going to have to write the equation with those 2 points. So the first thing you're going to do is plug in the ordered pair. We're at x equals 0. Then we're going to simplify the function and solve for A. Then we're going to plug in the second ordered pair and solve for B. So we have A, we'll have B, and then we can write the function that you found. So go ahead and pause here and write down these few steps before going on. Okay, so I want you to write an exponential equation in the form y equals ab to the x that goes through the points 0, 4, and 3, 2,916. So my first step is to use the point 0, 4 to find A. Okay, so I'm going to use the point 0, 4 to find A. This is my first step. So if I have y equals ab to the x, for y, I'm going to put in 4. I don't know what A is. I don't know what B is, but I do know my x is 0. Well, anything raised to the 0 power is just 1. That's one of my exponent rules. 1 times A is just A. So A equals 4. Okay, step 2 is I need to use the next point to find out what B is. So let's see. I've got Y. Let's just write down my point, 2,916. Got my Y, 2,916 equals A. Do I know what A is? Yeah, I do, because I found it in my first step. I don't know what B is yet. And then X is 3. So now I want to solve this. So the first thing I want to do is get rid of the 4, get rid of that A value. So I'm going to divide that by 4. So 2 B cubed. Okay, and then I want to solve B cubed. So I want to take the cubed root of both sides. So I just plug that in my calculator and I get 9 equals B. Okay, so I found out what A is, found out what B is, so I'm going to put it in my formula. Y equals A times B to the X power. So my final equation only has A and B substituted in. Y and X stay the same.